Hey guys, welcome back. We are going to jump right into everything you ever wanted to know about triangles. Some of this stuff is going to be a review, so bear with me on the stuff that you already know. We will get into some things that you don't. So just follow along, take your notes, and I promise there will be some new stuff in here in addition to the stuff you already know. All right? So we are going to start with classifying triangles by their angles. So the first option that we have is an acute triangle. And an acute triangle has three acute angles. Okay, so it could be something like 60 degrees, 70 degrees, and 50 degrees. Okay, I didn't get out a protractor and measure it, that's okay, but all of those are clearly less than 90 degrees. Okay, so that is the point there, is that we want an angle, or a triangle, excuse me, that has three acute angles. All right, an equiangular triangle is a triangle that has three congruent acute angles. So it means that all three of them are exactly the same. So we can go ahead and put arc marks in there and to show that they are the same. A right triangle has exactly one right angle. So if we draw a triangle and put our box there, we know that that means a right angle. So we have one right angle. Can't have more than one, okay, but we can have at least one, or we can have exactly one, excuse me. And then an obtuse triangle has one obtuse angle. Okay, so an obtuse triangle could be something like this, and let's say that's 100 degrees. Okay, that's more than 90, so we know that it is an obtuse triangle. All right, that's probably all stuff that you guys have done before, especially because we've talked about acute, right, and obtuse angles, so that should be pretty easy. This is probably a review also. An equilateral triangle has three congruent sides. So if we were to draw a triangle, the way that we would show all three sides are congruent are by putting our tick marks. Okay. An isosceles triangle has at least two congruent sides. So that would look something more like this probably. We've got these congruent sides that we can put tick marks on. Okay. And a scalene triangle means that we have zero congruent sides. None of the sides are the same length. So that could be something more like this. And the way that we might show it's scalene is by purposely putting different tick marks on each side. So even though these two might look like they're the same, because I put different tick marks on them, I'm showing you that they're not. Okay? So equilateral, isosceles, scalene, those are the three ways to classify triangles by their sides. So you do have to know the difference between classifying by its angles and by its sides. Cool? Moving on. Now we're going to talk about the parts of an isosceles triangle. So we just drew an isosceles triangle up here. We're going to draw another one down here. And I want to actually label it XYZ. All right, so we've got this triangle here, XYZ, and I'm going to say that it's an isosceles. So I'm going to put in tick marks on XY and XZ. That means that this is an isosceles triangle. Oops, might help if I could spell right, guys. Isosceles triangle with base YZ. Okay, so let's talk about some of that vocab that's over here. So we've got the legs of an isosceles triangle. All right, those ones are the congruent sides. So in our picture over here, that means that the legs are XY and XZ. Because those are the two congruent sides. Let's actually jump down to base, okay? It's the side that's across from the vertex angle. It's the one that's not congruent. Okay, so that's why over here I said this is an isosceles triangle with base YZ. YZ is the one that's not congruent to the other sides. Okay? The vertex angle is the angle that's formed by the legs. So when we look at our picture, xy and xz, they both share x, okay? The angle that's created there, that's our vertex angle. And it is across from the base YZ. Okay? Then we also have base angles. Base angles are the two angles that have the base as a side. That's pretty easy, right? Your base angles have your base as a side. So when we look here, YZ is our base. That means angle Y and angle Z are our base angles. Okay? So you need to be familiar with all of that vocab, because if we give you a problem and we start to talk about base angles and vertex angles and the legs of an isosceles triangle, you need to know how to draw what we're talking about. Okay? Moving on, we need to talk about the isosceles triangle theorem. Okay? So if we have two sides of a triangle and they are congruent, so two sides of a triangle are congruent, then the angles that are opposite those sides are also congruent. Okay, so if you look over on the side here, we're going to write a hypothesis and a conclusion. Hypothesis always starts with if, and the conclusion means then. So if whatever we were told, then whatever we're going to conclude. Think back to chapter 3 when we did if parallel lines, then corresponding angles are congruent, or the other angle pairs that we did. Okay, so this one says if two sides of a triangle are congruent. Okay, so I'm going to draw that then. So two sides of the triangle are congruent. That means like that. Okay, then the angles that are opposite those sides are also congruent. So my conclusion then is that the angles that are across are also congruent. So pretty much what that means is that in an isosceles triangle, the base angles are congruent. All right, the angles that are opposite those sides, that's a fancy name for those base angles that we just talked about. Okay, so I don't know if you had picked up on it, but in my picture, I even actually drew the arc marks to show that they were already congruent. Didn't do that on purpose, but that's okay. All right, then the converse of that, converse just means opposite. All right, so if two angles of a triangle are congruent, then the sides that are opposite those angles are congruent also. So this time we're starting with if these base angles are congruent, then the sides opposite are congruent. All right. Then we've got to talk about our equilateral triangle corollary. So if a triangle is equilateral, then it is equiangular. So in other words, if all the sides are the same, then all of the angles must be the same as well. So if we start with a triangle that has 3 congruent sides, then that means we also have a triangle that has 3 congruent angles. All right, so look at the differences between these. Isosceles triangle, we've got 2 sides congruent and 2 angles congruent. With equilateral, it's 3 sides congruent and we get 3 angles that are congruent. By the way, we haven't talked much about it yet, but 180 degrees is the total inside of a triangle. So if we divide that by 3, we actually get that each angle in an equilateral or equiangular triangle is 60 degrees. We'll talk more about that later too, but you might want to jot that down. Then we've got the equiangular triangle corollary, which says that if a triangle is equiangular, then it is equilateral. So it's the exact opposite of the one we just did. This one is saying that if we start with a triangle that's got 3 congruent angles, then that means that same triangle has 3 congruent sides. Okay. Down below, you've got your learning targets for this section. That was a lot of vocab, but I am going to show you guys just a couple of quick examples before the video ends, okay? So go ahead and flip to the next page, and let's take a look here. We want to classify the following triangles by their sides and by the angles, okay? So when we look at number 1, to classify by its sides, remember we have the options of equilateral, isosceles, or scalene. And then to classify by the angles, we have obtuse, acute, right, and equiangular. So if you need to flip back and look at those options, those are there. All 3 of these angles are acute, and we've got these tick marks right here to show that these 2 sides are congruent. This is an acute isosceles triangle. Okay. Number 2, the first thing that I happen to see right there, I see a right angle. So automatically I know it's right, and all 3 sides are different, so this is right and scalene. So right classifies it by its angles, and scalene classifies it by its sides. And then you guys are going to try number 3. Take a look at the angles and the sides and see if you can decide how to classify it by its sides and angles. So sides and angles. Go ahead and classify that triangle. All right, take a look at number 4. You guys have to start thinking about what some of these corollaries and theorems that we just talked about actually mean and how to apply them, okay? So we want to find the side lengths in the following triangles. And when you look at this triangle, we see 3 different expressions here, okay? The other thing that you should see is that there's a tick mark on JK and LK, excuse me, which means that LK is congruent to KJ. And anytime we have congruent segments, it means that we can set them equal to each other and solve. So LK is my x plus 3.2, and that has to equal KJ, which is 4x minus 1.3. And now we have an equation that we can actually solve, right? So hopefully you guys are good with your solving. If I subtract x from both sides, 3.2 equals 3x minus 1.3. Add my 1.3, and I get 4.5 equals 3x. Divide by 3, and I get that x equals 1.5. Okay, so that's not what it asked for though, right? It asked us to find the side lengths in the following triangle, which means I have to take that x value and plug it back in. So I'm going to need to figure out how long is JL, how long is LK, and how long is KJ. All right, so grab out your calculators, and we want to plug those in real quick. So 5 times 1.5 minus 0.2. This side length is 7.3. This one is 4.7. And this is 4.7. Now hopefully you guys would have been able to tell me without even thinking that LK and KJ are going to be the same, right? That's how we actually solved for it. So if you plug your x value in and you don't get the same thing, then you did something wrong with your solving, okay? So please make sure that you are actually doing that. All right, question 5 tells us that triangle FGH is equilateral. Equilateral means that all of the sides are congruent. All right, so what that means then, we can put tick marks on each one. All 3 of those sides have to be the same as each other. So what I would do then is just pick two of them. We can't have an equation with all three of them, but all three of them are the same. So pick two of them and set them equal to each other. So I'm just going to take GF and GH. I'm going to say GF is congruent to GH. So I've got 3y minus 4 equals 2y plus 3. And I can solve for y. So if I subtract 2y, I get y minus 4 equals 3. Add the 4 over, and I get y equals 7. So I found my y value. Now I need to actually plug y in and get all three sides. So GF, GH, and FH. And hopefully when you plug that 7 in, you should get the same thing for each one. So grab your calculators. We got a y value of 7. So 3 times 7 minus 4, and we get 17. 2 times 7 plus 3 is also going to give us 17. And 5 times 7 minus 18 is also going to give us 17. So that is our total right there. Okay? So you have to be able to look at the triangles and decide, okay, which pieces are congruent, how do I know that they're congruent, and set them equal and solve. Cool? All right, so take a look at number 6. So a manufacturer produces musical triangles by bending pieces of steel into the shape of an equilateral triangle. So equilateral is important. Equilateral means that we have 3 congruent sides. Okay. So how many 4-inch triangles can the manufacturer produce from a 100-inch piece of steel? So the important part here is that we have 3 congruent sides, and we want each side to be 4 inches. All right, so that means that one triangle is going to be equilateral. All 3 sides are the same, and they're each 4 inches. So what that means then is that each triangle there is actually going to be, it's going to use 12 inches of steel. Okay, so one triangle is going to be 12 inches of steel. Right, 4, 4, and 4. So we want to figure out how many can we make with this 100-inch piece of steel. So just do 100 divided by 12. Okay, if you've got your calculators with you, you should get that it's 8 and some. So we have to say that it's 8 triangles, because we can't have a portion of a triangle, right? We get 8 complete triangles, and we actually have 4 inches left over. Because if we make 8 triangles that are 12 inches each, it gets us to 96, and so we've got 4 inches left over. Cool? Question 7. So 7 and 8, we need to find the variable and the measure of the indicated angular side, and then we have to explain. Okay, so this is going to be the part that you guys are going to forget, I bet, because you don't always read directions. So we want to explain. This is where we're going to use some of those corollaries. Okay, so take a look at number 7, and if we look at it, we can see that we've got DF is 12, DE is this x plus 3. We're also told that angle F and angle E, they've got those arc marks. All right, so that means we have to be able to look at this picture and see that those angles are the same. So angle F is congruent to angle E, which means we started with these base angles being congruent. So if base angles are congruent, then we know that the sides across from them are also going to be congruent. So that means then that DF is going to be congruent to DE. It means that the sides across are also going to be congruent. So DF is congruent to DE, which means we can actually solve for x. DF is 12. 12 equals x plus 3. And then we can solve for x. So if we subtract 3 on over, we get that x equals 9. All right, so the explanation there that we're looking for is this right here. If base angles are congruent, then sides are congruent. So you have to be able to look at the pictures and pull from there what's happening. All right, so you guys are actually going to do number 8 on your own. So when you come into class, I'm going to be looking for, did you solve for x? Did you solve for the measure of angle B? And are you explaining it? Okay, so I want to see some sort of explanation, some sort of if-then to help justify your answer. I know this video was a little bit longer. I apologize, but we are going to spend 2 days in class actually working on this material because it's a lot. All right, I will see you guys later. Bye.